Good morning and welcome to Algebra 1 for Friday, May 15th. Today we're going to go over the worksheet which was graphing from standard form a quadratic equation. The first one's on the board. So, the first thing I said you had to do, always, is carefully identify the a, b, and c values. The a is always the number that is the coefficient of x squared. When there's no visible number that is the coefficient, it's the number 1. B is the number that is the coefficient of the x term. There isn't an x term, so the coefficient is 0. And C is the constant, in this case negative 1. So far, so good. Now, in order to find the vertex correctly, we want to use the little equation x equals negative b over 2a. In this case, b was 0, so it's negative 0 over 2 times 1, which is what a was, negative 0 over 2, which is 0. So the x value of my vertex is going to be 0 for this equation. Now I have to plug it into the equation to find what the y value is. Since y equals x squared minus 1, it's going to be y equals 0 squared minus 1, which is 0 minus 1, which is just negative 1. So my vertex is the coordinate 0, negative 1. Over here, I'm going to put my t-table. And the middle of the t-table is going to be the vertex, which is 0, negative 1. Remember that in order to fill out the t-table, we have to choose inputs that are 2 away from the vertex on both sides. So if that's a 0, that's a negative 1, that's a negative 2. That's a positive 1, that's a positive 2. So that will have some symmetries. We have the 5 numbers in a row, negative 2, negative 1, 0, 1, 2. They're 5 continuous numbers. The outputs are going to be symmetric about the vertex. So we have to plug them in to solve for each one. Negative 2 goes first. Use parentheses very carefully. When negative numbers are squared, they become positive. So that's going to be positive 4 minus 1, which is 3. So the input of negative 2 has an output of 3. Let's use negative 1 now. So y equals negative 1 quantity squared minus 1. That's 1 minus 1, which is 0. And I'm going to keep going. I know that we could stop there if we have confidence in our outcomes. However, I'm going to just do the other two problems for you so that we can verify it. So I'm going to use 1 as the input. 1 squared is 1. 1 minus 1 is still 0. And then I'm going to use the final input, which is 2. So y equals parentheses 2 squared minus 1, which is 4 minus 1, which is 3. Again, I'm not interested in busy work, so if you know what you're doing, you can do it more quickly than that. I would like to see you solve at least 2 of them with the math on paper so that we have the evidence to support your answers. All right, well, now I'm going to graph it. So I'm going to erase my work to give space for the graph. I need a little bit of negative y, mostly positive y, and even spaced on the x. So let's see, we've got 1, 2, to the right and the left, 1, 2, 3 up, and I'll go 3 down also, even though I don't really need that. Plot the coordinates carefully. Some of you are graphing strangely. Negative x's go to the left, positive x's to the right. Negative y's go down, positive y's go up. So please graph appropriately. Negative 2, positive 3. Negative 1, 0. 0, negative 1. 1, 0. 2, 3. We formed our parabola. We're just going to give it the curve, give it the arrowheads, and give it the thumbs up because we're done with this prompt. Hopefully everyone got it right. All right, number 2. Number 2, similar to number 1 in that there is a missing term. So let's take a look at it. Y equals negative 2x squared plus 1. All right. Again, identify your ABCs. My A is this time negative 2. The b term is still missing. There's no regular x term, so it's a 0 coefficient. Positive 1 is c. I know that so far we haven't really used c very much, but we will as we move forward. All right. What next? Find the x value of the vertex using negative b over 2a. Negative 0 over 2 times negative 2 is still negative 0 over negative 4. 0 over anything, still 0. The vertex is not always 0, but what you might be realizing is that when the b term is 0, the vertex x value will be 0. Plug in a 0. Okay, order of operations, this time doesn't much matter, but we're still going to do things right. 0 squared is 0. Negative 2 times 0 is 0. Y equals 1. My vertex is the coordinate 0, 1. So again, I'm going to make my t-table with 0, 1 in the center, negative 1, negative 2, positive 1, positive 2. Again, we find our coordinates by plugging in the values and being careful, as my child screams. Okay. So y equals negative 2 parentheses. I'm going to use that negative 2 as the input right now. So negative 2 quantity squared plus 1. It is important to use the order of operations here. The parentheses have no work to do inside of them, but there is an exponent. So y equals negative 2 times, negative 2 squared is 4 plus 1. Negative 2 times 4 is negative 8 plus 1, and that's negative 7. I know I did the work correctly. I feel confident. I'm going to put the negative 7 down here also because I feel confident it will reflect. It will be symmetric. It will be the same output. And then I'm going to do the other one, negative 1. So y equals negative 2 times parenthesis, negative 1 squared plus 1. Again, you can use a calculator to actually plug in the values to solve, but I want to see the work on paper as well. That's negative 2 times positive 1 plus 1, which is negative 2 plus 1, which is negative 1. So I feel confident that both the outputs for an input of negative 1 and positive 1 will be negative 1. Verify it by looking it over, make sure it looks right to you, looks right to me. And I'm going to graph. So what do I need to graph this? A lot of negative y and even on the x. So I'm going to just graph like this, because I need more negative y than I need negative x, or positive y rather. Okay, negative 2, negative 7 is the first graphable point, so negative 2, negative 7 is right about there. Negative 1 is right over here. 0, positive 1, it goes up here. 1, negative 1, and 2, negative 7. So we have this parabola that looks like this. Kind of missed the point there, but that's okay. Okay, so it's kind of narrow. Definitely points down. Remember, I also said that we'll know whether the parabola should point up or down, open up or open down, based upon the a value. When the a value is positive, it opens up like a smile. When the a value is negative, it opens down like a frown. And we had a negative a value, so it better open down. Okay. Now let's see if we can move through the other ones a little bit faster, maybe with less exposition. Number 3, y equals 1/2 x squared plus 2x plus 3. This time there's definitely an a, b, and c to find. There's nothing missing. There's 3 terms here. The a is 1/2. The b is positive 2. The c is positive 3. So far, so good. Yeah, there's a fraction. Who cares? It's fine. It's a number. You can work with that number. X equals negative b, that's negative 2, over 2a, that's 2 times 1/2. Please make sure you plug these in carefully because on some of your work you were kind of missing some of this. That's negative 2 divided by 1, since 2 times a half is 1. So we have an x value of negative 2. Now we're going to plug that in. Half of negative 2 squared plus 2 times negative 2 plus 3. I plugged in negative 2 where there was an x, and now I'm going to solve it. So y equals half of, that's going to be 4. 2 times negative 2 is negative 4, and then plus 3. Half of 4 is 2, minus 4, plus 3. 2 minus 4 is negative 2, plus 3 is 1. All right, and again, that can all be done on a calculator if you just plug them in using negatives appropriately, using parentheses appropriately. It shouldn't be an issue. So we have our vertex. It's at negative 2, positive 1. This time our vertex is not located at 0. So we're not going to choose the same numbers we chose before. We're going to go 2 away on either side. So negative 2 is going to go to negative 3 and then negative 4. And then on this side, negative 1 and 0. Again, 5 numbers in a row for the x values. And now I'm going to plug them in. So we're going to do, I'm going to do these two this time. I mean, might as well. They'll be reflecting regardless. Negative 1 and 0. So I'm going to do negative 1 first. Half of negative 1 plus 2 times negative 1 plus 3. Squared. Negative 1 squared, of course, is just 1. This is minus 2 plus 3. Half of 1 is a half. Minus 2 plus 3. Half minus 2 is negative 1 and a half. But when you add 3, you get positive 1 and a half. It's okay to get fractions. It's okay to get decimals, especially when they're easy to use, like halves. It's not hard to graph a half. And we'll do the 0 also. Half of 0 squared plus 2 times 0 plus 3. Take a look here. This is going to be 0. 0 squared is 0. Half of 0 is 0. 2 times 0 is 0. So really it's 0 plus 0 plus 3, which is 3. Little tip. When you've got standard form and you've got your ABC terms, when you plug in a 0, the answer will always just be that constant, that letter C. Positive 3 was C. When I plugged in 0, I'm only left with that. So 0, C, will always be a coordinate on your vertex. On your parabola. Okay, so I got that, and now I graph it. Again, we have negative x's mostly, except for the 0, and all positive on the y. So go 1, 2, 3, 4. 1, 2, 3, 4. Doesn't much matter what else I do. Negative 4, positive 3, so it's over here. Negative 3, 1 and a half. Negative 2, 1. Negative 1, 1 and a half. And 0, 3. And here's my parabola. And yes, it opens up because the a value is positive. It looks good, looks right. That's what number 3 should have been. Moving on to number 4. I gave you a correction for number 4 because when I made the worksheet, for whatever reason, I left out a number. I caught it early enough in the morning. Shouldn't have been a problem, but thanks to those who helped me. Number 4, y equals negative x squared plus 2x. All right, something is missing here, but it's easy to see. Again, the a value is the coefficient of the x squared, which is negative 1. The b value is the coefficient of x, which is positive 2. The c value is the constant, which is the missing piece, which is the number 0. Okay, not a problem. Find the vertex. X equals negative b, which is negative 2, over 2 times a, which is negative 1, which is negative 2, over negative 2, which is 1. The vertex has an x value of 1. Plug it in. Y equals negative, parentheses 1 squared, plus 2 parentheses 1. Parentheses are important because only the 1 is getting squared, not negative 1. So it's negative, parentheses 1, plus, well, 2 times 1 is just 2. That's negative 1 plus 2, because when there's a negative on the outside, when you finally multiply, the number becomes negative here. And that's just the number 1. Our vertex is at 1, 1. So I'll make my t-table 1, 1. So we'll go 0, negative 1 up here, 2 and 3 down there. So far, so good? Okay, great. Plug them in. I don't know if you can hear the birds outside my window, but they're loud. I'm going to plug in the number negative 1. So y equals negative, parenthesis, negative 1 squared plus 2 times negative 1. There's so many negatives here, so please be careful. So we got negative 1 squared is 1. And then 2 times negative 1 is just minus 2. So this is negative 1 minus 2, which is negative 3. So that's a negative 3 up here and also down below, because I'm just going to fill it in. It's going to be symmetric. And then we'll do the other one as well, which is going to be our input of 0. Oh, an input of 0 is nice and easy, because I just said that when your input is 0, your output's going to be whatever the c value is, the constant. And the c value in this case was 0. So I know without even doing the work, those are going to be zeros. If you want to just take a look at it real quick, if I plug in zeros for x, I have negative 0 squared plus 2 times 0. It's just 0. So we graph them. All right, I got negative 1, 2, 3, positive 1, 2, 3 on all sides. Might as well. Negative 1, negative 3 is down here. 0, 0's over there. 1, 1's over here. 2 zeros over there. 3 negative 3's down there. And I have my parabola as such. Don't forget the arrowheads. Why does it open down? Because the a value is negative, negative 1, making the vertex the maximum, where it increases to the vertex and it decreases away. Okay. One last problem for today, and then we can all take a break. And as we come to number 5, I'll let you in on the secret for tonight's homework. There's no homework. Number 5, y equals 3x squared plus 6x minus 2. Finally, the last problem. Here we go. And by the way, it's faster than this. You don't have to take 20 minutes to do 5 problems. I'm drawing it out. I'm showing you every step. Obviously, you wouldn't have to do it quite as much. A is 3, B is 6, C is negative 2. X equals negative 6 over 2 times 3. That's negative 6 over 6, which is negative 1. Y equals 3 times negative 1 squared plus 6 times negative 1 minus 2. Why did I do that? To plug in the x value to find the y value. Y equals 3 times 1 minus 6 minus 2. That's 3 minus 6 minus 2. That's negative 5. My vertex is negative 1, negative 5. Negative 1, negative 5. So that's going to be negative 2 and negative 3. 0 and positive 1. And let's plug them in and solve. Hey, look, there's a 0. I love zeros. Zeros are awesome. What are you going to get when you plug in a 0? Negative 2. So I know that's going to be negative 2, and I also know that this will be negative 2 because it is, again, say it with me, symmetric about the vertex. It's going to reflect. So that gives me a 1 or a negative 3. I would much rather plug in 1 than negative 3. Y equals 3 times 1 squared plus 6 times 1 minus 2. 3 times 1 squared, so it's 3 times 1 plus 6 minus 2. That's 3 plus 6 minus 2. That's 7, which is going to reflect. And my t-table is now filled out without too much worry or stress. So how do I graph it? Well, the same way I graph everything else. Y value goes up to 7 down to negative 5. So there's a lot of y action going on here and only a little bit of on the x. So I have to count kind of tightly here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4. Okay, so here's my coordinate grid. I got -3, +7. So 3 to the left, 7 up. 7 up. -2, -2 down here. -1, -5 down there. 0, -2, which is, whoops, I just put that in the wrong spot. Let me just fix that real fast. That was -1, -5. I put it on the axis. 0, -2 up here, and then 1, 7 up here. Very narrow. A tight turnaround. It points up because of the positive leading coefficient, positive A. Vertex is the minimum. Hey, we're done. I hope it wasn't too difficult for you. I know that there were some concerns as we went, but if you're very careful, what you might notice is that the only concern you have is that it's the order of operations and negatives and careful graphing. There's no homework this weekend. Enjoy the weekend. I hope it's nice weather, and we will reconvene on Monday. Have a good one.